Imagine a game where you roll a die and win money depending on the number you get. But here's the question: how much money should you expect to win on average? Not in one game, but over thousands of games. This idea is the foundation of discrete random variables, one of the most important topics in Edexcel S1 statistics. In this video, we're going to master every single concept in this unit, including what discrete random variables are, probability distributions, expectations and variance, linear transformations, modeling real situations, and how to solve exam questions step by step. By the end of this video, you'll be able to solve any exam question from this chapter. In this lesson, we'll cover the following topics: random variables, discrete probability distributions, probability tables, expectations, variance and standard deviation, linear transformations, and exam-style modeling problems. Let's start from the very beginning. Random variables, which are variables whose value depends on the outcome of a random experiment, such as tossing coins and rolling dice. Now, discrete random variables are random variables that can only take specific separate values, usually integers, meaning full numbers, not decimals. For example, if a fair die is rolled only once, let x be the number shown on its face. X has 6 possible values, being 1 through 6, and the probability of each value being shown on the face is equal, and all of them equals 1 over 6. And this is because this die is fair. Now let's talk about probability distribution. It's usually written as a table, where x is the possible values. So in this example, the possible values are 0, 1, and 2. The probability of 0, which is denoted as p of x, or p of x, which is the discrete random variable, being equal to small x, which is this 0 or this 1 or this 2. So the probability of x being 0, which is the small x, is 0.2. And the probability for big X, the discrete random variable, to be equal to small x, which is in this case here 1, is 0.5. And the probability for 2 is 0.3. Hence, we can discover that this experiment is not fair, because the probabilities are not equal. One general rule you must always keep in mind is that all probabilities add up to 1. They must add up to 1. You might see this rule, which is really important, and you have to know it for your exam. It's very simple, even though it might look a bit daunting. This symbol is the sum. So the sum of the probabilities, this is probabilities, of the discrete random variable x being equal to x each single time is always 1. So this expression just means that the probabilities combined in the entire experiment must equal 1. Let's take this problem for example. We have an unfair experiment, or just a biased experiment, same meaning, and the probabilities combined are 0.2, 0.4, 0.1, and this k. If we go back to the formula we just talked about, the sum of all the probabilities here should add up to 1. Hence we know that 0.2 plus k plus 0.4 plus 0.1 must equal 1. And if we subtract all these numbers, we're left with k is equal to 0.3. Now part 3 of our lesson is the expectation, or the mean, or E of x. It's basically the long run average value, or the mean of the distribution. And this is the formula of the mean. It might look a bit daunting, but it's very simple. For example, if we have this distribution table, the mean would be these two multiplied plus these two multiplied plus these two multiplied. The number that is the possible value multiplied by its probability, in addition to the other number that is the possible value multiplied by its probability, and the same as we go on in the table. And then we add everything up. So 0 multiplied by 0.2 is just 0. Plus 1 multiplied by 0.5 is 0.5. Plus 2 multiplied by 0.3 is 0.6. 0.5 plus 0.6 plus 0 equals 1.1. And this is our E of x, or our mean. So we interpret that the expected value is 1.1, meaning over many trials the average outcome will be around 1.1. Around, not exactly, because this is still an experiment and there's a margin for error. Let's take this problem as an example. So let x capital X be the number shown on a fair die, meaning that the possible outcomes are 1, 2, 3, 4, 5, and 6, and the probability for each one of these outcomes is 1 over 6. And hence we can find the mean, which is each value multiplied by its probability, added to every value multiplied by its probability. So 1 multiplied by 1 over 6, plus 2 multiplied by 1 over 6, plus 3 multiplied by 1 over 6, so on and so forth. Just plug this in your calculator, the answer is 3.5. So the average result of rolling a die repeatedly is around 3.5. Even though 3.5 is impossible in one roll, it represents the long-term average, which is basically the mean. The next part of today's lesson is variance. So far, we learned how to find the expected value, which tells us the average outcome of a random variable. But expectation alone doesn't tell the full story. Two distributions can have the same mean but behave very differently. One might have values that stay close to the mean, while another might have values that vary a lot. So we need a measure of spread. That measure is called variance. Think of variance as answering the question, how far on average are the outcomes from the mean? A small variance indicates that values stay close to the mean. However, large variance indicates that values are spread out more. Now this is the variance formula, and it does look a bit daunting. However, it's very simple. The variance of x is equal to the mean of x squared minus the mean of x entirely squared. And these aren't the same thing. Let's have a look. So firstly, to find the variance of x, we need to find two things: the mean of x and the mean of x squared. So to find the mean of x, it's basically simple, just as we talked about. 1 multiplied by 0.2 plus 2 multiplied by 0.5 plus 3 multiplied by 0.3. It's basically every possible value multiplied by its probability added to the rest of these elements. So now we found that E of x, or the mean, is basically 2.1. So now let's find the E of x squared. Firstly, we need to find x squared. So we have three values for x in this example: 1, 2, and 3. 1 squared is 1, 2 squared is 4, and 3 squared is 9. So now we have all the values for x squared. So the mean of x squared is basically every value for x squared multiplied by its probability, added to the second value of x squared multiplied by its probability, added to the third value of x squared multiplied by its probability. If we have more values, we're going to keep going on. So if we just plug in this calculation in our calculator, we're going to find out that the mean of x squared is actually equal to 4.9. So now we have the mean of x squared and the mean of x. Now we can calculate our variance. So now let's go back to our formula. The mean of x squared, which is 4.9 as we just found out, minus the mean of x, which is 2.1 as we found out before, squared. So 2.1 squared, which is 4.41. So 4.9 minus 4.41 is basically 0.49, which is our variance. We have now another measure for statistics, which is standard deviation, which basically tells us the typical distance from the mean. The standard deviation is simply the square root of the variance. So in this case, our standard deviation will be square root of 0.49. The square root of 0.49 is basically 0.7. So here it means outcomes are usually about 0.7 units away from the average or the mean. And this is the interpretation for the standard deviation. In Edexcel S1 exams, variance questions almost always follow the following pattern. Firstly, they give you a table, and then you compute e of x, and then you compute e of x squared, and then apply the formula of the variance or the standard deviation. Variance is standard deviation squared, and standard deviation is basically the square root of variance. This symbol is what we use to indicate standard deviation. Once you practice this structure a few times, it becomes mechanical and very easy for you. Now we move on to one of the most frequently tested ideas in this chapter. Sometimes the variable we care about is not x itself, but a transformation of x. For example, in profit, scaled marks, currency conversions, and the scores with bonuses. These are written as y equals ax plus b. What do the a and b here mean? A basically changes the scale and b shifts the value up or down. For example, if we have y equals 3x plus 2, we take this x variable, we multiply it by 3, and then we shift it or add it by 2. And any transformation we make could work in any other measure in statistics. For example, the mean of ax plus b is equal to a multiplied by the mean of x plus b. Notice something very interesting here. The constant b does not affect variance. Why? Because variance measures spread, and adding a constant shifts all values equally. So let's take another example. Suppose that the e of x equals 4, and the variance of x equals 2. Let y equals 5x plus 3. We need to find the mean of y and the variance of y. So the mean of y is equal to 5 multiplied by the mean of x plus 3, where the mean of x is basically 4 multiplied by 5 added to 3, which is our answer, 23. This is the mean of y. Now when we want to calculate the variance of y, we don't do the same thing as we did with the mean. We ignore the b and square the a. This is just something you need to keep in mind for the calculations of variance in transformations. We ignore the b and square the a. So the variance of y is equal to 5 squared multiplied by the variance of x, which is basically 2 multiplied by 5 squared, which is equal to 50, which is the value of the variance of y. So just remember, in terms of variance with transformations, we ignore the b and square the a. I'm talking about the form y equals ax plus b. In Edexcel exams, this question often appears as just 2 lines. Students who remember the formulas can answer it in 10 seconds. And now we're going to talk about the cumulative distribution function, or CDF for short. So until now, we've been working with probabilities of the form P of x equals x, which means the probability that the random variable takes one exact value. But in many exam questions, we are asked things like the probability of x being greater than or equal to 2, the probability of x being less than 3, and so on. To answer these, we use the cumulative distribution function, or CDF. And the definition of this is f of x, which represents the cumulative function, is equal to the probability of big X being less than or equal to small x. So for a quick example, suppose the following table. The probability of x being 0 is 0.1. The probability of x being 1 is 0.3. The probability of x being 2 is 0.4. And the probability of x being 3 is 0.2. Now normally what you will see in your exam is, for example, this. The probability of big X, which is the discrete random variable, being less than or equal to 2. So basically, the probability of big X being 0 or 1 or 2, less than or equal to 2. So not 3, not 3. We're not looking at 3. So the probability of X being 0 is 0.1, plus the probability of X being 1 is 0.3, and the probability of X being 2 is 0.4, and this adds up to 0.8. So the probability of big X being less than or equal to 2 is equal to 0.8. And something to keep in mind is that the final cumulative value is always 1, because the probability of X being less than or equal to the maximum value is always equal to 1. And finally, we're going to talk about discrete uniform distribution. And this occurs when all outcomes have the same probability. So back to our basic die example. For example, if I roll a die, I'm getting the outcomes 1, 2, 3, 4, 5, and 6. And each of these probabilities will be 1 over 6 because the die is a fair experiment. It's not biased, right? It's unbiased or fair. So running a fair die, and this is discrete uniform distribution. For discrete uniform distribution, calculating the mean of X is pretty easy. It is just n plus 1 over 2, n being the number of all the possible outcomes. So again, in this case, it will equal 3.5. And the variance is also pretty simple in discrete uniform distribution. It is always equal to n squared minus 1 over 12. So in this case, it would be 36 minus 1 over 12, which is basically 35 over 12, and this would be the variance. And this will be all for today's lesson. So in this chapter, we covered probability functions, cumulative distribution functions, expectation or mean, variance and standard deviation, transformations and calculating variance and the mean using transformations, and the discrete uniform distribution. And this will be the entirety of the discrete random variables topic covered. If you need any help, be sure to contact me. My contact information is in the description and bio. And thanks for watching.